Welcome back. Today we are going to dive into a classic coding challenge, the valid parenthesis problem. This problem is not only a great exercise in coding skills, but it's also an excellent opportunity to understand how the stack data structure works. So, let's jump right in. First, let's understand the problem statement. So, if we go through the problem statement, the problem says we are given a string S containing just the characters, open parenthesis, open flower brackets, and square brackets, open and close. We have to determine if a string is valid. So a string is valid if open brackets are closed by brackets of same type. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. That means if we look at the example, a simple parenthesis is a good example. A parenthesis, square bracket, flower bracket is a good example. So the output is true in both these cases. Whereas in the third example, there is a open parenthesis and a closed square bracket. Open parenthesis doesn't have a matching closed one. So the output here is false. So if you take examples like this. So we have a open square bracket. This is also not true. Here also we should return false, because though the number of open and closed brackets match, they are not in the right order. So how can this be correct? It can either be like this or like this. Okay. So all these are, this is a invalid case. This is a good case. This is also a good case. Okay. So we have to match a parenthesis with its closing parenthesis. A open flower bracket with a closing flower bracket. A square bracket with a closed square bracket. Or if we don't find such thing, the output is false. So what are the constraints we have? The string has at least one character and the string contains only these letters. So we need not check if there are any other characters other than this. Okay, so let's try to understand it through an example. So here, if you see this example, what we are essentially saying is we have to match the closing bracket with the latest opening bracket, which is nothing but last in first out, which is like a stack data structure that we have seen. So let's say we have a stack like this and we traverse this string character by character. Whenever we see a open bracket, let's put it in the stack. So in the first place we are here, it's an open bracket, so it goes into the stack. The second one is a square bracket, it goes into the stack. The third one is a closed bracket. Okay, so when we see a closed bracket, we pop out the item from the stack. So we take this from the stack and compare if our current element, what is the current one? Current is closed square bracket. Compare if they are a pair. If it is a matching pair, then we continue. Okay, so this is also a valid case. Now we are at 4. 4 is open bracket. What do? We again push. We deleted the element here, so we can put it here. Next one is a open flower bracket. So we again push. Next one is a open parenthesis. We again push. So the next one is a closed parenthesis. So what do? So the current element is closed parenthesis and we pop the element from the stack, which is the open parenthesis. Okay. So both of them match, they are a pair, so it's again valid. We continue. Next, the next element is a closed flower bracket. It's a closed one, so we pop the element from the stack. So this is already popped, so our stack is currently here. So the next element we pop would be open flower bracket, and the current element is this one. Both are a matching pair, so it's again valid. Now we continue. The next element is closed parenthesis. Okay, so this one is popped out, so stack top is at here. It's a closed parenthesis, so it's again a valid scenario. We pop the element from the stack, we compare it with the current element, both are a matching pair, so we continue. Now our stack top is at here and we have a open flower bracket. The current element is closed bracket, so we pop the element from the stack and compare it with the current element. Both are a pair, so it's again true, so we continue. Now we have reached the end of the string. We are here. That means we have parsed all the elements in the string. Now at this point, if the stack is empty, that means we have matched all the brackets. So our stack pointer is here, we popped this element as well, which means our stack is empty. So this one is a valid string. Okay, so what did we do? We put, whenever we see a open bracket, which is any of this, push to stack. Whenever we see a closed bracket, which is any of this, we pop from stack and check if a pair exists. Check for pair. If a pair exists, then it is a matching bracket and we continue. If the pair doesn't exist, we can return false straight away. So at the end of the string, once we reach the end of the string, if the stack is empty, that means we have found matches for all the things. If the stack is not empty, we haven't found a match. So this is going to be our algorithm. Let's see it with another example. So here in this example, this is the string we have. Okay, so again we will start traversing the string character by character. Initially we will be at this open parenthesis. First we will initialize a empty stack. Our current element would be at iteration 0. Our current element is open bracket. If it's open bracket, we push it to the stack. Okay, we push it to the stack. So okay, then the next element at iteration 1, so at iteration 0 it's open bracket, at iteration 1 it's square bracket, it's again a open bracket, so we push it to the stack. At iteration 2 it's a open parenthesis, it's again a open bracket, so we push it to the stack. Okay, at iteration number 3, okay, our current element is 0, 1, 2, 3, so we are here, is closed square bracket. Okay, so if it's a closed bracket, what do? We pop the element from the stack. So what is the element from the stack? From stack. Okay, when we pop, what do we get? We get open parenthesis. So since we popped the element, our stack pointer will go here. This is removed from the stack. So we have a closed square bracket and a open parenthesis. These two are not a pair, so this is not a valid string. So at this point we can just return false. Okay, let's try and code this example. So clearly, to code this use case, what data structure do we need? We need a stack. So in Java there is a stack data structure, and by default you will be tempted to use it. So if you go and see the documentation, it clearly says that do not use stack, but rather use the modern data structure DQ. Okay, stack is a vector data structure which is there only for legacy reasons. It is not implemented, right? So it's better to avoid it. It is there since JDK 1.0 and it is present only for backward compatibility reasons, nothing else. Okay, so we will use this DQ data structure. So let's just copy this string to initialize the stack. We can, so our stack is a stack of characters. Okay, so instead of integer I changed it to a character. Now we have a stack. Initially it's an empty stack. Okay, so what do we do for each character C in s dot to char array? Okay, so we are traversing through each character in the string. So if it is, what is our logic? What was our algorithm? If it is any of the open brackets, you push it to the stack. Okay, so if it is open bracket, I'm just using a function to make it more readable, that's all. If is open bracket, we push it to the stack dot push the character. Else if, so what is our else case? If it is a closed bracket, remember it can be only these three characters. You need not check for other character types, that is there already in the constraints. So if it is a closed bracket, if it's not an open bracket, then it is obviously a closed bracket. Then we have to pop the element from the stack and compare if it is a pair. So before we pop the element from the stack, we have to check if the stack is empty or not. Okay, if the stack is empty and if we try to pop, then we will get an exception saying we are trying to access an empty stack. So first we will check if the stack is empty. If the stack is empty and we have a closed bracket, means is empty. We have a closed bracket means we can return false. Okay, or is, if it's not a matching bracket. Okay, we return false if either the stack is empty or if it is not a matching bracket, and we do this for the entire length of the string. Finally, at the end, if the stack is empty, then it is true, otherwise it's false. So we can simply return stack dot is empty. Okay, now we have two functions to implement. Okay, one is boolean is open bracket. What is it taking? Char C. So what does it check for? If C equal to open parenthesis or C equal to open flower bracket or C equal to open square bracket, then we have to return true. Okay, that means if any of these three characters match, then it's a open bracket. What is the other function we have? Is matching bracket. So for this we have to take the character also as input. Okay, so the current character we have, which is pushed to the stack, and the whatever we pop from the stack. Okay, these are the two elements we have. Okay, now we have two characters here, left bracket, or maybe let's call it open and close. So it can be any open and any close. Okay, when will it be a matching bracket? If open equal to parenthesis and close equal to closing parenthesis. So this is one condition. Okay, just for clarity, let's put it in a, and we have three such conditions. Or open is flower bracket and close is closing bracket, or open is square bracket and close is square bracket. So in all these cases, okay, it is a matching bracket. If it is not a matching bracket, then what do? We return false. So if it is a matching bracket, we just continue. So let's run this and see. Okay. Okay, here the order should be reverse. So here what happened? We were passing them in the wrong order, open and close. Whatever we put in the stack was a open bracket, that is why we should pass the open first, and whatever we have at the current is a closed bracket. So this one succeeded, it ran in 1 millisecond. So what is the time complexity and space complexity of this? If we check the time complexity, we are traversing the input array or input string until we reach the end of it, which is order of n, where n is the size of the string. This is very simple. Here space complexity is a bit complex. Okay, so if you observe properly, we are using a stack data structure. In best case, when you find an immediate match always, which is like this example, we will be using only one element. But if it is something like this, let's say something like we have to put the entire array and then pop and see. So it will take at least n/2 times space in the stack, which is why our space complexity would be order of n. It is also in the size of the input. So we should not always just consider the best case complexity, we should also look at the worst case complexity. So here n is the length of the string. So there you have it. We have successfully tackled the valid parenthesis problem using a stack data structure. I hope this video has been insightful and has helped you understand not only how to approach this problem, but also the power of using stack in various coding challenges. Before we finish, I encourage you to try this problem on your own. Practice is the key to mastering these concepts. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe to our channel for more coding content. Thanks for watching. Happy coding.